everyone, I'm here today to talk about the timeline of historical development of the atom. But for now, I'm gonna introduce myself first. I'm Lyka, 16 years old from grade 11 Sardonyx. What's the first thing that comes to your mind when you see this? What I'm gonna do today is to give you the information you need to know. Okay, first thing, let's talk about the historical development of an atom. What is atom? Atom is the smallest part of a substance that cannot be broken down chemically. Each atom has a nucleus, or the center, made up of protons, positively charged particles, and neutrons, particles with no charge. Electrons, which are the negative particles that moves around the nucleus. The word atom actually comes from an ancient Greek word atomos, which means indivisible or cuttable. So I think you've now got a good understanding or a little background about atom, right? Okay, so let me now move on to the early atomic theory. The atomic theory, which holds that matter is composed of tiny indivisible particles in constant motion. This was proposed by the Greek philosopher Leucippus and Democritus in the 5th century BC. He used the word atomos to describe this particle. The theory of Democritus held that everything is composed of atoms, which are physically but not geometrically indivisible. However, Aristotle did not accept the theory. It was ignored for many years. Aristotle did not believe in the atomic theory, and he thought so otherwise. He thought that all materials on Earth were not made up of atoms, but the 4 elements, which are the earth, fire, water, and air. He believed all substances were made up of small amounts of these 4 elements of matter. Modern atomic theory begins with the work of John Dalton, published in 1808. He held that all atoms of an element are of exactly the same size and the weight, and are in these respects unlike the atoms of any other element. Evidence for Dalton's theory also came from Michael's Faraday's law of electrolysis. He proposed the law of multiple proportions. Solid sphere model. This was the first atomic model and was developed by John Dalton in the early 19th century. He hypothesized that an atom is a solid sphere that could not be divided into smaller particles. Plum pudding model. The plum pudding model is one of the several historical scientific models of the atom, first proposed by J. Thomson in 1904, soon after the discovery of the electron but before the discovery of atomic nucleus. The model tried to explain 2 properties of atoms, then known that electrons are negatively charged particles and that atoms have no net electric charge. Ernest Rutherford. In 1911, Rutherford described the atom as having a tiny, dense, and positively charged core called the nucleus. Rutherford established that the mass of the atom is concentrated in its nucleus. The light negatively charged electrons circulated around this nucleus, much like planets revolving around the sun. His model is called planetary model.
Planetary model.
Niels Bohr model. In 1913, he proposed a theory for a hydrogen atom based on quantum theory that energy is transferred only in a certain well-defined quantities. The model proposed by Niels Bohr is one that you will see in a lot of introductory science text. There are a lot of good ideas in this model, but it is not the one that agrees with all the current evidence. The model tries to make a connection between light and atoms. James Chadwick. In 1932, James Chadwick proved that it consisted a neutral particle with about the same mass as a proton. Ernest Rutherford had earlier proposed that such a particle might exist in atomic nuclei. Its existence now proven, it was called a neutron. Neutron helped to reduce the repulsion between protons and stabilize the atom's nucleus.
This is the Chadwick model.
Atoms are very important in this world. It helps people understand how elements of this world do. And that's why we need to learn and discover more to help our society and also our planet.
Summary of the discussion. Hope you learn a lot from this video. Thank you.